Okay, so I'm gonna go over this in a separate video. This is calculating the percent abundance of isotopes. I went over this in class, and I noticed a mistake when I was about to post the notes. I accidentally, I don't know how I read 0.9553, it was 0.9533. So it gave me the wrong answer on the second one, and I figured I would trim the other video anyways because it was like approaching an hour in length. So I wanted to make sure that you guys got the correct answer on the video. The math was correct. I just plugged it in the calculator wrong. So anyways, I'm going to go over this super quick. It shouldn't take me more than 10 or 15 minutes. So the atomic mass on the periodic table is actually an average of all of the isotopes of that element. So the way this is calculated is you have average atomic mass equals whatever this element is, first isotope, times the percent abundance, which is how often it is found in nature or in the universe, plus element isotope 2 times percent abundance, and let me rewrite that A so it doesn't look like crap, but and so on. It can keep going. It just depends on how many isotopes there are. Not too much to it. It's essentially an average. So one thing that this problem doesn't give us is it doesn't give us the masses for N14 or N15, which we do need, so I looked them up. It was 14.003074 AMU. You could probably get away with just doing 14.003, but whatever. This one is 15.000108 AMU. So we don't know what the percentage is. What we have to do is make a system of equations. So when you only have two isotopes, it's pretty easy. You just set it as x and 1 minus x, because this symbol symbolizes 100%, and then this is just anything that's not 100%. So it's super easy to solve. So the way we do this is, I'm going to color code these. So blue is going to be for numbers, and red is going to be for the x's. So we have 14.007 equals, red, 003 now. I'm making mistakes again. I'm going to just put 00374 with the whole thing, times x, and then this is plus 15.000108. This should have been blue. And then that is times 1 minus x. Alright, so now we just FOIL this out, solve for x. Super easy. So we have 14.07 equals 14.003074x plus 15.000108 minus 15.000108x. So now we just combine like terms. So that means I'm going to subtract on this side, and then I'm going to combine these two. So I'm going to be clear this. I have 14.007 minus 15 point. Oh, wow, not 150. So we're going to get essentially 0.993. Usually if you're rounding to about the thousandth place, you're good. So that is equal to whatever this is. So about negative 0.997. Sure, it was a negative. Doesn't really matter in the grand scheme of things, but we're going to solve this, essentially you're going to divide this out. And x is going to be equal to whatever this is. And I know I didn't use the negatives, it's kind of pointless. So you get about 0.996. So in percentage world, that would be equals, so since N14 has a percentage of x, it has a percentage of 99.6%. So since, or 0.996, because that's what the decimal version was, N15 is equal to 1 minus x, so that is equal to 1 minus 0.996 equals 0.004 equals 0.4%. And that's how you do, little simple ones with two isotopes. I mean, nowadays it's kind of pointless because you could just go to Wikipedia and look it up, but it is a good skill to have because it does help you with other things. So those are the answers for this one. I'm going to do one more. It's a little more tricky. This is the one I entered the wrong number for. It happens. So, and plus you get a shorter video, so it makes it a little better. And I know this screen capture works a lot better than Microsoft Teams. So, anyways, the average mass is for silicone 28.0855. I'm gonna just color code that right off the bat. So silicone 28 is a mass of 27.9769. Silicone 29 has a mass of 28.9765, and then silicone 30 has a mass of 29.9738. Silicone 29, we know that it has a abundance percentage of, or percent abundance of 4.67%. So in decimal form, that's 0.0467 because you're just dividing by 100 on that number. So we need to find out what are the natural abundances of silicone 28 and silicone 30. So silicone 28, we're going to label it as a percent abundance of X. Silicone 30 is going to be equal to Y. So Y is going to be equal to 100, so 1 minus this percentage, this is X, 0.0467 minus X. So I'm going to simplify this even more because this is where I messed up. I don't know how I saw that, but it just happens. 0.9533. I put 0.9553. So this one is going to be 0.9533 minus X. So that's going to be its abundance percentage, or percent abundance. So now we just have to label this in an equation. It's the same thing. We're just solving for X. So this equals 27.9769 times X plus, it's going to be 28.9765 times 0.0467, and then that's plus 29.9738 times, let me make sure it's color coded. You need to understand manner. 0.9533 minus X. So we see what is going to be the like terms. So let's go ahead and FOIL everything So I have 28.9765 times 0.0467. This is going to be about 1.353. And then this one is going to be a little different because I didn't screw up this time. 0.978 times 0.953. So this is going to be 28.9574. 28.9574 minus. The only reason I'm coloring the minus is because I just want you to know that you put that with the number for this one, just to make it easier. Alright, so we're going to combine like terms. Alright, so adding this together, you're going to get, alright, it's just a pain in the butt to use that calculator, so 40, it's 10, 11, 9, which that's probably wrong. Yeah, I knew it was wrong. Oh, it's because I didn't carry the 1. Whatever. Okay, 30.3104. Sorry, I'm tired. Minus 29.9738x and 27.9769x. Alright, so this is what this equals. We have to combine like terms again. So essentially what we're going to be doing is subtracting this number from this side of the equation over to here. So we have 28.0855. Yeah, did I give you 28.9? Watch, I probably put the wrong number in there. Yeah, I did. I knew it. 0.574. I was like, there's no way that should be that high. It's higher than the actual mass of the isotope. So anyways, this one's a lot easier. 7219. Yeah, there we go. That works a little better. So ignore the first part. It's actually this number. I don't know what I was thinking. Anyways, so we're going to subtract this number over here. Good lord, I cannot math today. So this equals, I don't know off the top of my head. Negative point, I guess like 0.184. I probably did something wrong, but because I got a different number earlier when I solved it, but that's fine. So we're just going to leave it as this is equal to this number. So you have 27 blah 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 minus that. So it's a lot harder when I don't have a calculator in my hand and I'm doing it on the computer. I don't know why that is, it just doesn't compute for me. Negative 1.99 600x. So I'm going to just divide this out. And that's going to give me x, which is something I want. Oh yeah, negative. That 1.841 divided by 1.9969, and you're going to get about 0.92, and I probably rounded or something like that, but that's fine. So this equals x. That means x is equal to 92.1%. And then now we just plug in x here. So that's going to be equal to so let's do that then here, just so you can see it. So we have 3, 2, 3. So about 0.323 equals 3.23%. We're off by a little bit off of what the record said, but it's fine. And then this one's going to be 4.67%. So we have figured out the percentages of all. So this one is the most abundant, which makes sense. Silicone 29 is equal to 4.67, so we already knew that. And then silicone 30 is equal to 3.23%. And it's probably going to be over by like 1 or something like that. That's fine. It's not a big deal. Actually, it should be right at 100%. Because I rounded. But that's how you do these. They're not super complicated. They're a little more complicated if you are doing these with a calculator on the computer. But anyways, if you have any questions, just ask me in class.